It's been a little bit laggy recently, so I'm hoping it will speed up as we move through. Okay, so the first task was the sort of typical 4 questions, covering stuff that we've done recently and stuff we've done slightly longer ago, just as a recap. All of the answers are there, but I'm just going to talk you through these as we go. So as before, with your answers that you've done on your presentations already, just add and amend and improve those. And I would encourage you to try and do it in purple, because it makes it more useful for me when I'm looking at them, so I can see the differences between how you've improved them and what you did originally. Okay, so first, state 3 features of an alcohol. So I've done more than 3, but I only asked for 3. So the first important feature of an alcohol is it contains a hydroxyl group, which is an OH. Okay, so it's got an O and a H attached at some point on the carbon chain. Because it's got an oxygen in it, it's not a hydrocarbon. Okay, so that might seem like a weird feature to state, but it is important that you recognize alkanes and alkenes are hydrocarbons, and alcohols and carboxylic acids, esters and amines and the other things we'll talk about aren't. The general formula is CnH2n plus 1 OH. You could have said they are slightly acidic, and the reason they're slightly acidic is because of the OH, the hydrogen on the OH. Remember, acids donate hydrogens. So that hydrogen on the OH can be lost. So most alcohols are slightly acidic, but only slightly. They're usually weak acids. They can undergo combustion reactions, so they can be burnt. And the bit that we covered right at the end of last lesson is if you react an alcohol with a carboxylic acid, you can form an ester. Okay, and we'll be talking more about that later. The second question was make 3 comparisons between ethane and butene. So the main things that you can pick from this is, first of all, you can identify the type of chemical that each one is. So ethane ends in ane and therefore is an alkane. Butene ends in ene and therefore is an alkene. And so butene, because it's an alkene, contains a double bond. It's therefore unsaturated. Whereas ethane, because it is an alkane, has no double bonds at all, only single covalent bonds, and therefore we can call it saturated. The other thing that you can make a distinction about both of these is the first bit of the name, so eth and bute. So eth means 2 carbons, so ethane only has 2 carbons, whereas butene has 4 carbons. And the other thing you can say is because they're an alkane and an alkene, they're both hydrocarbons. So that's sort of broadly what you could do. There are additional points you could have put. So you could have maybe thought about the fact that because butene has a longer chain, it will therefore have a higher boiling point because it's got more intermolecular forces between the individual chain molecules, which brings us neatly to fractional distillation. So describe the molecules at the top of a fractionating column was the next question. So at the very, very top, we're dealing with the very short chain molecules. Ethane would be an example of that. In fact, butene is short enough that it would generally come out at the top of the fractionating column, or butane at least. But all molecules at the top have very short chains, so that means they've got small carbon length. They've got low boiling points because they don't have very strong intermolecular forces. They are highly volatile. Volatile or volatility refers to how easy it is for something to ignite, how easy it is for something to sort of catch fire and light. Short chain molecules are very volatile because initially they are gases. And then obviously as the chain gets a little bit bigger and the boiling point gets a little bit higher, they do turn into liquids. And at that point, because they're still on that edge between gas and liquid, they light very, very easily. So they're still very, very volatile. In comparison, think about the opposite end of the spectrum. If you've got bitumen, which is like tarmac effectively, if you were to like flick a match onto some tarmac, the tarmac isn't going to catch fire. You could get a flamethrower on tarmac and it isn't going to catch fire. So it's got a very low volatility. just think how easy it is to light a Bunsen burner in the lab. It's also got a low viscosity because obviously initially it's a gas, but as it becomes a liquid, as you go down the fractionating column, those liquids, are very, very runny in comparison again to bitumen, which is very thick. And last point is its light in colour. So again, you didn't need to have all of those points, but that's all of the sort of main points that you could have had. And the last question on here is explain the process of cracking. So cracking we covered 2 lessons ago now. And it is the idea that the very long chain molecules like bitumen that we get at the bottom of the fractionating column aren't actually that useful. So what we do to them is we crack or split those long chain molecules into a shorter chain alkane, which is more useful because we can burn it more easily, and a far more useful alkene. Right, that creation of a molecule with a double bond makes a huge difference, because if you have a double bond, you can attach stuff to it, and you can begin to do far more complex chemistry with an alkene because of the double bond than you could ever hope to do with an alkane. Alkanes are quite boring. The only thing that you can do with them is set them on fire, really. Not that that's a boring thing, it's fun to set them on fire, but alkenes are far more useful in the grand scheme of things. And you could have also put the point that in the actual process, in terms of the method, that you heat it over porcelain because that's the catalyst. But the main point is just what we're actually looking to do, which is to break a long chain alkane into a shorter chain and a more useful alkene. Okay, so moving on then. Obviously, I asked you to take some notes on there, which obviously will look different for all of you, so I can't really summarize that, but I will look at what you've done. The next task was to write definitions for each of these keywords. So again, you can see I've put the answers, but I'm just going to talk briefly through this. So unsaturated means that you have a double bond, okay? And just in terms of why we use that term, if something's saturated, we mean that it has the maximum number of hydrogens that can be attached. So unsaturated means you could saturate it further and add more hydrogens and therefore remove the double bond. Covalent bond, the key phrase that you must have for this one, because this is a very common exam question, like what is a covalent bond, is you must have the phrase shared pair of electrons. Okay, remember covalent bonds are about sharing. Ionic bonds are about one losing and one gaining electrons, but covalent bonds is all about sharing. Hydroxyl group is the OH. It's the oxygen and hydrogen that's attached at any point on the carbon chain, and we have seen those so far in alcohols and carboxylic acids. The carbonyl group is a C double bond O, so it's a carbon with a double bond towards the oxygen, and we have seen that so far in carboxylic acids. Okay, I'm going to point out those two things in a little bit more detail in a bit. That we also would see those in aldehydes and ketones as a different kind of molecule. Hydrocarbon. Now the definition for this is pretty straightforward, but there is an important word in here. Okay, so it's a molecule that contains carbon and hydrogen. The important word is the word only. Okay, if I was doing this on a whiteboard, I would, at this point, I would underline the word only. Okay, that's the important bit. You must have that word. And lastly, fermentation is just one of the processes by which we manufacture alcohol. And in the case of fermentation, we take sugar, we ferment it by adding yeast, and that will produce ethanol and carboxylic acid. And we also talked in the past about the advantages and disadvantages of fermentation. So the fact you can only produce alcohol up to about 14% because the yeast becomes denatured because the pH increases and so on and so forth. Okay, so next you were asked to organize the information around the fractionating column. So here is one I did earlier in true Blue Peter fashion, just to save a bit of time. So first of all, the blue boxes, you can see at the very top we have refinery gases, then petrol, then naphtha, kerosene, diesel, lubricating oils, and bitumen. And obviously we have crude oil coming in at the very bottom on the left-hand side. And just to reiterate, crude oil is just a mixture. Okay, it's all of these fractions are all together just in one mixture in crude oil when we extract it from the ground, and that's why we need to separate them. You can then see in the green boxes what the uses of each of those are. So refinery gases at the very top are used as bottle gases. So literally the kind of bottled gas that you might have outside, next to your barbecue, or you would have around the back of a caravan, or any of those kind of things. It's the same bottled gases that we use in the lab, which is methane. Naphtha is used to manufacture chemicals. I'll obviously say petrol and diesel. I didn't put anything for, because I assumed it was fairly obvious what we use petrol and diesel for. We use them for motor vehicles. But naphtha we use to actually manufacture chemicals. It's just about the right length to make it really useful to make the kind of molecules that we use frequently. So naphtha is really useful. Kerosene we use for jet fuel, and we use paraffin for lighting and heating. Lubricating oils, the clue is in the name. We use them for lubrication, typically in engines. So if you've got a place where you're going to have a very hot environment like a car engine, but you don't want the oils to burn, you need something with a low volatility, and therefore you need a long chain molecule to act as that lubricating oil. And bitumen we use for roads and roofing. And then you can see in the red boxes, and you can broadly put these wherever you want, but I've just put them, the three that apply at the top of the column are light in colour, low boiling point and high volatility, as we saw on slide number 1. And obviously in contrast to that, the bottom of the column has very large carbon chains and a high viscosity. Okay, they're very thick. So I hope that is clear. In terms of, will you be asked to label or know each of these points in your exam? Yes. So they might, a very common question is they will give you a version of this diagram, and they will say, they will have bits unlabeled, or they will have bits labeled X, and you've got to say what X is, and so on. So, and then they like as well to say, okay, naphtha comes out at this level, what do we use naphtha for? So they will ask you those kind of questions. So be prepared for that. Okay, so now we move on to the 6-mark question, which is, look at the displayed formula of propene. Propene can react together to make a polymer. Write what happens when propene molecules react together, and include in your answer the description of the reaction and the name of the polymer made and the conditions needed. So this may initially not have seemed to have made much sense until you watch the video on polymerization. Then I would hope that this then becomes quite an easy question. Breaking down the actual question, looking at a level 3 response. So you need to describe polymerization, okay? And you'll see how that manifests itself. So in terms of the conditions needed, and I'm hoping you remember that there are 2 conditions for addition polymerization, which we'll cover in a second. You have to give the name of the polymer. Now, I hope if you've watched the polymerization video that was not too much trouble for you. I know we talked about how difficult that is, but I hope that wasn't too hard. And then quality of written communication does not impede your communication. So in essence, all you've got to do is describe what happens in polymerization, what are the conditions, and what's the name. Okay, for 6 marks. So get ready for this. The name. If we're starting off with propene, we're going to get polypropene. That was tough. That cut real deep. So there's 2 marks for you for sticking the word poly at the word of the front and the front of the word propene. Don't forget to put it in curly brackets as well. It's for added difficulty. So polypropene is the polymer we're going to make. Okay. The 2 conditions are with addition polymerization, you have to do it at high pressure, and you need a catalyst. The mistake that people sometimes make on this is they just automatically go, you just need a high temperature. You don't need a high temperature, but you do need high pressure. Okay. So it's nothing to do with temperature. You need a catalyst and you need high pressure. Don't put temperature. Don't assume that you need a high temperature. And then the actual process, we're going to break the double bond and join up all of the individual monomers to form a long chain polymer. And a drawing of that will help. And I'm just going to go back over that process of drawing in a second. So this is the actual full scope of the answers. Okay. So conditions are high pressure and a catalyst. You can see that at the top. And then you can describe the actual process in a whole variety of ways. But the simple idea is propene is a very small monomer molecule. And because it's got a double bond, and it's an alkene, that double bond is going to break. And it's going to join together lots of the individual monomers to form a long chain. The long chain is the polymer. That's called a polymerization reaction. Called an addition polymerization because you're adding them together. and the name is polypropene. You can see there that you can use curly brackets or without. They're not too fussy, but I would always put it with curly brackets. And then you can see an example of the drawing at the bottom. Okay, so that's our 6-mark question. Hopefully that wasn't too difficult. Okay, next, evaluate the differences between compounds A, B, C, and D. So again, I've already put the answers here, but just talk through them, because some of these we will have been more familiar with than others, because this is an application question, so it's just about thinking about what we know in the context of what we've covered. So I'm just going to start with compound C, just because it's probably the easiest. So compound C is ethene. It's got 2 carbons, so it's eth, and it's got a double bond, so it's an alkene. What we would then say is, well, all the things we know about alkenes must be true. So it's a hydrocarbon, it's unsaturated. Because it's an alkene, it would turn bromine water colourless, because that double bond can react. Because it's got a double bond, it can undergo an addition reaction. That addition reaction could be an addition polymerization, for example. So it could form polymers, would be another thing you could put for that. If it did form a polymer, it would be polyethene. Okay, all of those are things that we can say about compound C. So that's compound C, done. Next, I'm going to do compound B. So compound B, again, has got 2 carbons in the chain. So again, it's eth, but it's got a carbonyl group, which is the C double bond O, and a hydroxyl group, which is the OH. So if it's got both of those, it's a carboxylic acid. And therefore, it's not a hydrocarbon. The other thing we've said so far about carboxylic acids is they can combine with alcohols to form esters. Okay. And I will say, you don't need every single one of these points. Okay. This is just about you thinking about the differences between each of these molecules. The other thing you could say is, it occurs in the name, carboxylic acid. They are acidic. And again, it's because that hydrogen that's attached to the oxygen can be removed and dissociate. Okay, next, let's do compound D. So compound D should have made sense again after you watch the video on polymerization. So its actual name of it would have been polychloroethane, and obviously it's a polymer because it's in square brackets and it's got the little N there and the sticks at the side. That represents the repeat unit. The actual other name you could use for this is polyvinyl chloride, but we don't need to worry too much about that. It's formed from the monomer of chloroethene, and you need a high pressure and a catalyst to do that. It's formed in an addition reaction. That's largely just a summary of what we know about polymerization so far. You could have said that it'll be a plastic. That would be another thing that you could have put, because all polymers are plastics or rubbers. And lastly, compound A. So it looks like an alkane, but it has a bromine on. So this is what we call a halogen alkane. So it's an alkane with a halogen attached. The actual name of it would be bromopropane, because it's got 3 carbons, so it's prop. And the main points I would want you to have picked out on this is just 2 points. Number 1 is it's not a hydrocarbon. And number 2, it doesn't contain any double bonds, therefore it's not saturated. Sorry, it's unsaturated. It's not unsaturated, it's saturated. So just, they will give you molecules like that you'll be less familiar with, okay? But you'll only be asked to categorize them based on the ideas we've discussed. So for example, is something a hydrocarbon or not a hydrocarbon? Is something saturated or not saturated? Does something contain a particular functional group? Okay, and moving on. So last activity here was to review each of the first 3 main functional groups we covered: alkanes, alkenes, and alcohols, and just make sure we've got all the key information about them that we have covered. So you've got the general formula for each one. So alkanes are CnH2n plus 2, alkenes CnH2n, and alcohols, as we saw earlier, CnH2n plus 1 OH. Alkanes and alkenes are both hydrocarbons. So actually this box here, the hydrocarbon box, can be dragged to be over both of these. Okay, it doesn't have to just be in one. I'd actually put it on this middle line. Alkanes contain single bonds only. Propane is an alkane because it ends in ane. and they're saturated. Propene would be an alkene, and obviously propanol represents alcohol. They contain hydroxyl groups and can be made either via fermentation or hydration. We've covered and evaluated both of those. And then the other points about alkenes are about cracking and about how they discolor bromine water. That's the test for unsaturation, which is when we have a double bond. Okay, so that should have been fairly straightforward. And then we've got your individual review, which I'll come back to shortly. Okay, now at this point, that's it for our organic chemistry side of this. So I'm going to stop the recording for Google Meets in a second because I'm not going to be looking at Jamboard in quite the same way. But that covers the review of what we've covered so far. One other thing is, in about 2 minutes on Classroom, a question is going to appear for you that I'd like you to answer on Classroom. It's a really simple question, so there's nothing to panic about. I just want to know a general question from each of you, how you've been coping so far with what we've covered in terms of chemistry. Have you been finding it okay? Have you been finding it difficult? Have you been pulling your hair out and struggling? Have you been like drinking mojitos and sunbathing whilst you're doing it because it's way too easy? How have you found it? It's just what I really want to know. Is there anything that you feel would be more useful to have more of, less of, and so on? Just a general check-in, really, and also any suggestions that you have for what you'd like to cover next week. Now, bear in mind, because of the amount of time we've got in school, I can't cover everything next week, but I will do my best to try and cover things that it is that you specifically want me to. So just put any general ideas there, and I will, even if I can't cover something next week, that doesn't mean I can't do a video on something and share it with you. Okay, so I'm just going to stop the Google Meet recording at this point. But now I'd like you to go over to Jamboard.